Hola, hello, and welcome to the Tech Geek Podcast. I'm your host Sukriti, and I'm here with another episode on fraud detection. Its federated network intelligence technology has led to an uptick in intelligence sharing between payment operators to prevent fraud. More importantly, it helps to distinguish between genuine spending behavior and fraudulent ones. When these models are trained for a specific merchant or sector, it helps improve fraud detection accuracy by as much as 40 to 50%. Even the industry under the NPCI is creating a common platform for data sharing that can be used across payments platforms to serve as a repository of all the fraudsters. Guys, today I'm in conversation with Damon Madden, Principal Fraud Analyst from ACI Worldwide. Damon has over 15 years of experience and precise in depth expertise spanning the full spectrum of digital payment channels. This deep domain expertise, combined with innovative strategic leadership, allows him to seamlessly translate business requirements into market leading solutions. Welcome to the show, Damon. I'm elated to have you here with me today.
Thank you so much. It's a real pleasure to be here with you today. Thank you.
So, without any further ado, let's get started, Damon. So, the first thing that I would want to know from you is what are the latest advancements in ML with regards to the fraud detection that you see right now?
Yeah, there's two pieces here that I'd like to discuss where we're seeing sort of innovation at a rapid pace with regards to machine learning and in particular with regards to fraud detection. The first is incremental learning. So it's a key advancement that we've really been focusing on heavily here at ACI, and it's something that we've been actually awarded a patent for. So it's introducing the idea that having models that incrementally train themselves over a period of time so that they can naturally move with the fraud trends and predict what types of fraud patterns are happening within the environment or whatever type of detection that you're doing. The other aspect where we're seeing a lot of advancement is around bringing machine learning closer to the business. So the idea that machine learning is something that should be, harnessed by data scientists, harnessed by PhD students, and people that are highly technical in the way they approach, mathematics or whatever it might be. We want to remove that barrier of entry for people such as a fraud operator or a business user or someone that's embedded within an operational organization, to give them the skills and to give them the knowledge and the ability to actually build, train, and deploy models easily and rapidly. And these are the two areas where we're sort of seeing vast advancements from our perspective. We're constantly doing our own research and development in these two areas. And it's what we're really focusing on in terms of how we want to see machine learning being utilized for fraud detection in future.
All right. So tell me, what are the popular ML models currently being used in the industry?
Yeah, so there's several different approaches that we're seeing in the industry for models, okay? What we mainly see, which is still probably the most popular and still the most effective, is a regression approach to detecting fraud using machine learning. Why this is the most popular is it scales really easily is probably the first item that's worth mentioning about that. Secondly, the mathematics is easy to understand and interpret. So it's relatively easy to build a regression model, understand how the regression model is actually interpreting the data that's receiving, and then supplying you the outcome. So, the ultimate score that you might have as a result of that. So it's still very much the most popular approach because, it's relatively low expertise required to use that and to leverage that within an organization. Other areas where we're seeing popularity is more around neural networks. I mean, we're always hearing about neural networks. This is ongoing. I mean, you hear Tesla talk about neural networks and how they're utilizing that in the car industry. We still see that as quite a popular option for fraud detection, particularly where you have vast amounts of data, areas such as authentication, behavioral biometrics, these types of things. We also have other random forest models. And if we move more further afield outside of fraud detection and start thinking about financial crime management, we see a lot of k-means clustering type models for determining how a consumer might behave in relativity to their peers, and how that can be utilized for, ongoing due diligence or for fraud detection purposes as well.
Okay, so talking about ACI specifically, Damon, tell me, how do you build sector-specific ML models to improve the fraud detection?
We have a vast lake of data specific to payments and payment industries. So building models to a specific sector within our environment is relatively straightforward. So we have the data that's associated with a particular sector, okay? So we have all of that data available. And we understand that, like sectors, the fraud patterns may be similar across those. So we can easily apply those different learnings that we have across all the different segments. Now, when we think of our merchant base that we do fraud detection for using our Redshield product, we have specific sector models that are built for our customers. We also have custom models as well. However, we do use varying approaches. We have a full model pipeline to do that. And we're able to do that with relative ease, just simply for the fact that we have vast amounts of data available to us. When it comes to our on-premise customers, or what we would describe as our banking clients, it gets a little bit more tricky, where we don't necessarily have as much data available to us. And with those, we really focus on more outside of the area of sectors, and we sort of look at the channel or the payment type, and then secondary to that would be sectors.
Wonderful. So, Damon, help me understand how incremental learning models are improving fraud detection when compared to static models.
Yeah, of course. So with regards to incremental learning, we know that fraud patterns change. So as controls begin to impact the profitability for the criminal, right? So as their MO starts to become less profitable to them, it will change, right? So they will try some new avenue, or they will try a different merchant, or they will try a different approach to utilizing the exploit that they're using to, extort funds from a bank or a merchant or whoever it might be. And that change in behavior doesn't necessarily correlate to static models, right? So with the static model, if the behavior changes, the model's not necessarily trained against that change. Therefore, you'd start to see a degradation in performance, okay? So with that in mind, with incremental learning, what we see is, rather than having a static approach, the incremental approach will start to see a trend change. And as such, those new changes will be slowly introduced into the modeling process and slowly introduced into the model. And as such, as the trends change, or if the trend changes rapidly, then the model will also change rapidly. So the scoring algorithm starts to move with the fraud trend and how the fraud pattern is actually happening. Where the incremental approach really starts to become more effective, though, is when we start to think about sentiment, right? So when it's all well and good to wait for fraud marking, right? So you have incremental learning approach, you have fraud marking. We know that with fraud marking, typically within a banking industry, that usually you'll know about 95% of your fraud within 5 days is usually how that is. So there's a lead time of 5 days between an event and ultimately knowing what happened under that event. So rather than looking at the fraud, you can utilize an incremental learning approach to start understanding the sentiment of the users or the operators that are actually utilizing the system and actually looking for the fraud on a daily basis. And they can then use that information to then apply it to the fraud detection process, okay? So if you want to think of an example, an experienced operator may see a change in behavior. They might see something that's out of the ordinary, and they will block an account, or they may call a customer, or they may do something like that. So that information can be leveraged by an incremental learning process to say, hey, I'm seeing a change in behavior here. And as a result of that change in behavior, I might change my detection strategy approach to do something differently. So what do I mean by that? So with a fraud detection engine, what you usually have is you have 3 states, right? You have a post-facto state where a transaction comes in, it generates an alert, you do something with that alert. We then have a second state, which is what we describe as real-time decline. So where we intervene in the transaction path. So transaction comes in, we determine whether it's high risk or not. If it's high risk, we might choose to decline that activity. We might choose to hold a payment. We might choose to do something to that. And then the third is, of course, applying a block, so suspending an account from actually being able to transact any further than what it has already. So having an incremental learning model approach, you can have a sentiment comes in. So if you're starting to see someone block more accounts due to a particular trend, whether it be, maybe the ATMs in Mumbai are starting to become higher risk, and we're starting to see more of the operators that are using the fraud detection engine block those accounts associated with that, we could autonomously have a model that says, hey, I'm starting to see a change in behavior. Maybe I want to do something differently. Maybe I want to block all those accounts. Maybe I want to real-time decline those accounts. And you start to influence the fraud detection process while you're in flight and while you're moving through that life cycle of fraud detection. And that's kind of really a value-added benefit of using this approach where, static models would just never be able to actually move or adjust with that sort of timely manner in order to facilitate that type of detection.
That was wonderfully comprehended, Damon. I must say, what an understanding. Next one, and this is the last one. What is the need for a data sharing platform to curb banking frauds?
Yeah, that's a good question. So data sharing amongst the community is going to be the key to future fraud detection. Most criminals now are working in syndicates. We're not working with isolated individuals who are extorting a bank or an industry or something like that. We're talking about highly organized criminal syndicates that are doing this with the sole goal of profiteering. So as they're starting to share information, we are also going to start needing to share information. The ability to rapidly ingest data from multiple sources is also going to be really important. And of course, regulators are also going to want to understand the fraud detection environment, and they're going to want to understand that in very much in real time. So we know it doesn't come with problems. It doesn't come without problems, right? Managing diverse jurisdictions, privacy laws, everything associated with that. And as we know, India has some of the strictest laws in relation to data sovereignty around the world, including data processing. Like everything has to be done locally. So the ability to share data amongst that group is key, right? So the ability to share. So what do I mean by all this? I'm kind of skirting around the issue in terms of what it is we're talking about. But the data sharing platform and the ability to share data amongst the community is how you're going to prevent fraud at an industry scale, right? So it could be a jurisdiction level, so it could be at an India level, it could be at a global scale, it could be anything like that. Without having the ability to share indicators of fraud amongst different communities or amongst a community, you're never going to be able to get the upper hand against a criminal, right? So naturally here at ACI, this is something we really believe in, and it's something that we have a product for. So it's called network intelligence. And we really firmly believe in this idea that having a community of data is really key. And the other component of that that's really key is being able to share that data without compromising the privacy or the personal information of your customers. So, these are the real considerations around what you need to do with regards to sort of data sharing within a community. And we really believe that there is going to be a future where data sharing is key, right? That future is going to exist. It's starting to exist today in places like Australia or South Africa. We have SABREC in South Africa. We have the Australian Financial Crime Exchange. Everyone's starting to start up these sharing networks in order to facilitate sharing amongst the community, but also to get law enforcement involved, right? Because law enforcement are getting reports of a financial crime event over here, a financial crime event over there, but they're not necessarily seeing the whole picture, right? So the ability to actually be able to aggregate all of that information, push it to the central, whatever the central body might be, and then aggregate that information further, distribute it back out to the members of your community, but then also leverage that intelligence that you're gathering about that to assist in the law enforcement process or assist in the regulators' understanding of financial crime or whatever it might be within the environment. And we really, really firmly believe that this has a big future for fraud and financial crime detection.
Thanks, Damon. I think those were some enriching insights you've shared with us on fraud detection. Thank you so much for sharing them with us.
Yeah, no worries. Anytime. Thank you.
Audience, thank you for listening to us. Hope you had some great takeaways. I'll be back with another podcast episode super soon. Time to sign off. Stay tuned to TechGeek for all the latest tech updates and happenings.